In today's video, we're going to take this brand new Kraton EXB and try to power it with this 2-cylinder engine. And we're going to do it using what's hidden in these 3 boxes. I also have a gasoline conversion kit for this engine, assuming we get that far, but first we need to build it. This is a 4-stroke, 2-cylinder overhead cam engine, which is actually pretty similar to what most of you guys have in your full-sized cars. I have no idea if this engine's actually going to be powerful enough to drive the Kraton, but it's going to be a fun project, and I think we might learn something along the way. Speaking of which, this is the crankshaft. This is what turns the up and down motion of the pistons into the rotational motion of the output. I'm just going to be using some nitro engine afterrun oil as assembly lube. That should work just fine. It's a nice light oil, and it should keep things lubricated during the initial startup. This next piece going on is going to be for the starter belt. It actually has a one-way bearing in it. This is also known as a sprag bearing or sprag clutch, and you can actually see how it works through the cover. It has these angled solid blocks in here, and if you spin it one way, they get out of the way, but if you try to spin it the other way, they jam up and actually drive what you're trying to drive. Going on next is the flywheel. This is basically just a heavy weight. The flywheel stores energy and smooths out power delivery during the 4-cycle engine's operation. When we actually put this engine in the Kraton, we're going to be replacing some of these parts with a clutch, but for now, we'll leave it just like this because we're going to test this before we put it in, just to make sure it actually works. Next up are the pistons, and these are going to go in the cylinders. Between the pistons and the connecting rods, these are what actually take the explosive force from combustion and convert it into mechanical motion. By the way, even though I'm not showing it, I am using assembly lube on every step of this. Next, we install the crankshaft and the connecting rods to that crankshaft. As you can see, as the pistons go up and down, powered by the burning of whatever fuel you're using, that energy is turned into rotational motion, which then powers whatever it is the engine's powering. In this case, hopefully an Arrma Kraton. Next step is to put together the head. This is the thing that actually covers those cylinders. As you can see here, there are valves in either cylinder. These valves open and close to allow fresh air in and exhaust out, and those are controlled by the lobes on this thing, which is called a camshaft. Now, this is where the 4-stroke nature of a 4-stroke engine comes into play. As each piston goes up one time, the intake valve opens, letting fresh air and fuel in. That then closes, the piston goes down, it comes back up, you have your combustion, it goes back down, and then on the way back up again, the exhaust valve opens and lets the used gas back out again. A 2-stroke engine combines a bunch of these functions to where every single time the piston goes up, combustion occurs. Now we're going to put that cylinder head on, and this thing's really starting to look like an engine. I'm really excited to hear this thing run, so let me get the rest of it put together. And there she is, guys. This thing definitely looks the part of an awesome engine, though I'm a little bit concerned it's not going to have the power to actually push the Kraton like we want it to. We're just going to have to find out. And if it doesn't have the power on nitromethane, it might have the power on gas. I did get this kit from Engine DIY along with the gasoline conversion, and this gasoline conversion has the cutest little spark plugs I've ever seen, and I'm hoping we're going to be able to make them work on this engine later in the video, but for now, let's see if it's even going to fit on the chassis. I've got a spare Kraton EXB V6 chassis here, and I'm thinking about putting the engine kind of where the electric motor was previously. Let's get the center differential installed and see if that's even going to be a possibility. I've been wanting to put one of these engines in a Kraton for quite some time now, and I'm really excited to see how it works out. Hopefully we're not about to be really disappointed by the fitment. So we've got the center differential here. I do have a clutch kit that's going to be going on the end of this. I haven't installed yet. And yeah, it looks like it probably is going to fit. It's going to be really close though. I've got this plate of aluminum we're going to be carving a mount out of, and that should space it up just about perfectly. But before I do any of that, I want to make sure this engine actually runs. For that, I want to carve a mounting plate out of this piece of wood, and to do that, we need to build this beast. This thing includes a dual extruder 3D printer, a 40-watt laser cutter, and a 200-watt CNC machine, and in this project, we're going to be using all 3 of them. The first thing I noticed about these modules is how heavy they are, and that's because they're made basically completely out of metal. This is an extremely high quality, beautiful piece of kit, and I'm really excited to see how it performs. In order to do that, we're going to have to put it together first, and to assemble it, we're going to be using these big, beautiful linear modules. Again, this thing is an absolute work of art. It weighs a ton, it's got a cover for all the internal working bits, and is just one of the most beautiful things I've ever seen. Just starting the assembly on this thing, I can tell you that they really put a lot of time and effort into making everything fit perfectly. These base pieces are absolutely gorgeous. They even give you jigs that make it much easier to put everything together. The columns have support brackets, which should really stiffen everything up. Even the screws seem to be custom made for this machine, and they're really nice. The base is one solid piece of die-cast aluminum, and this thing is heavy. This is the main platform that all of the different build surfaces are going to go on, and as you can see here, they've really paid attention to detail. This is a little bronze bushing that the latch actually bears on. This is something that's really not necessary, but will make things smoother in the long run. Seriously, just look look at this control box. This thing could have been made out of all plastic, but this is made out of thick, heavy gauge aluminum instead. It's got all custom design connections on the back and a big, beautiful 7-inch touchscreen on the front. All right, now let's go ahead and get the firmware upgraded on this thing and put it to work. The first thing we're gonna do is 3D print a chip extractor for the CNC. It doesn't come with one out of the box, and I think it's really important, especially since I'm not gonna be putting this included enclosure on just yet. This thing looks really awesome, but it would prevent us from being able to see what's going on. Okay, I canceled that print because it was turning into a stringy, blobby mess. It seems like the default Lubin PETG profile really isn't that great, but let's go ahead and switch over to Orca Slicer where I can do some calibrations, and then we're gonna try this again and see if it works any better. While it's cooking, let's go ahead and get the truck prepared. I don't wanna use the M2C chassis that we have on this truck right now, because not only are we gonna have to modify it for the mount, but we're gonna have to modify it for brakes as well. I also want to keep at least the initial test version as light as possible because, again, I'm not sure how powerful that engine's going to be, and I definitely want to see it move under its own power and hopefully jump. So really all we need out of this truck are the front and rear ends and just a few of these bits out of the middle. Because we're going to be using mechanical brakes, we're going to be needing a custom mix on our transmitter, which the stock transmitter is not going to be able to do. Fortunately, I've got that MT12, which can do just about whatever you want. The modularity of this makes it pretty easy to strip apart and take the parts that we need and leave the parts we don't. While we were doing that, the 3D print finished, and I think this is a pretty acceptable result. I also went ahead and printed out the rest of the dust collection system. This is the part that's going to go on the CNC module, and then we've got a little dust shoe here. And hopefully this is going to keep things nice and clean while we're cutting without the enclosure attached. Speaking of which, now we need to get the artisan swapped over from 3D printing to CNC mode. Using this, we're going to go ahead and cut out the design I created for the temporary motor mount. There we go. I think that looks pretty good, especially for a cheap piece of wood with paper covering it, but let's see if the engine fits. It fits down in the little notch, but unfortunately, I think I made my holes in the wrong place. Of course, that's my fault, not the machine's fault. I'll make a quick modification to this board, let me get all this stuff mounted up, and we'll see if this thing can make some noise. All right, guys, let's see if this thing's gonna run or if this project ends right now. Well, there you go. Let's get this thing in the car. First step to doing that's going to be installing this clutch. Unfortunately, the clutch kit doesn't come with instructions, but we should be able to figure it out. First step's going to be to take that nut off. Then I'm assuming they want us to install this spacer and then the clutch shaft. I'm going to use just a little bit of thread locker on here and we'll screw this on. Then go in these two teeny tiny little grub screws that I think are going to act as hinges for the clutch shoes themselves. And now those clutch shoes go in. And then finally the clutch bell. All of that was necessary so we can tell exactly where the engine needs to be mounted on the chassis. But in order to figure that out, we need to go ahead and mount the center differential as well. Instead of using a standard center differential, we're going to use the center locker, which completely locks the front and rear outputs. I'll explain to you why we're doing this in just a minute, but for now, let's get this mounted up. And in order to do that, I think we're going to have to cut these motor mount tabs off because I believe they're going to interfere with the clutch bell when we install it. So I'm going to go cut these off. Let's get this mounted up and see where this engine actually needs to be on the chassis. Okay, now we can finally determine if the motor is going to fit and where it's going to fit. It actually does look like it's just barely going to clear everything back here, so yeah, let's make this motor mount. After taking some measurements and drawing some lines, as you can see here, I've created a model. The bottom piece of this references the 3 motor mount screws, and then the top piece is the actual mount for the new engine. As you can see, I've got this modeled up to where we're going to have slots so we can adjust the engine back and forth on the chassis. Now, before I go ahead and start cutting up some expensive metal, I want to make sure all this stuff's actually going to work because I'm sure I've made some mistakes. This is where the third function of the artisan is going to come into play. We're going to switch the build plate over to the laser base and the head over to the laser module, and that's going to allow me to cut the parts out of paper before I cut them out of metal. This kind of rapid prototyping is the real beauty of having a laser cutter. It took about 20 seconds to cut these out, and now I can actually use them as a reference to see how my design's going to work out. As you can see, these 3 holes line up fine, and 3 of these slots are good, but this 4th slot actually comes off the edge of the chassis. I think 3 slots are going to be fine, so we'll just get rid of the fourth one. We can also take the motor mount and hold it up against the motor, making sure that all the mount holes align properly, and they do. And then most importantly, we can take the motor mount, put it on top of the slots, put the motor on top of that, and then sanity check all my measurements to make sure it looks like everything's gonna line up. And as you can see, it looks like it's gonna line up pretty well. I have to say, I'm really starting to warm up to the Snapmaker Artisan, being able to change from 3D printing to laser cutting to CNC machining in just a few seconds, and for it to all be in the same machine really is nice. Speaking of that, let's go ahead and switch it back over to CNC machining. Now, before we machine the slots in this chassis, we've got a bit of a challenge. This thing doesn't really have any square corners or edges, so there's not any great way to reference where these slots need to go. What we're gonna do to overcome this is take these 3 motor mount holes and go ahead and bore them into the wood fixture first. Then once that's done, we're gonna take our chassis, lay it on top of those 3 holes, and screw the chassis in using countersunk screws. These 3 holes are gonna perfectly align the chassis where it needs to be, and now we can go ahead and finish the operation, cutting the slots in, and we can be very confident that those slots are gonna be exactly where we want them to be. As you can see here, that worked really, really well. I wasn't cutting very fast, but the finish is absolutely beautiful, and this is 7075 aluminum, which is a bit harder to cut than 6061. The slots look like they ended up in a good location, and there weren't even any burrs off the machine. Overall, I'm very impressed. Off camera, I also went ahead and machined the motor mount, and I got so excited that I decided to machine it twice. Now, what really happened was I broke off a tap in this one, and that just scraps the part. I'm not getting that tap out of there by any conventional means. As you can see here, I did go ahead and cut out the second part on my Carvera Air. This is a dedicated CNC machine, and I wanted to compare the results of the two just to see which one came out better. And to be honest with you, they came out very similar. The one off the Artisan does look a little bit rougher around the edges, and we've got a bit of a burr here on the top, though I was able to use a chamfer bit to clean up the tops of these, so that's not really a fair comparison. As you can see, I also added a bit of an angle here to clear part of the chassis that I didn't realize I was going to have to clear before. I do want to mention that depending on where you look in the Snapmaker Artisan documentation, it might say that it's not designed to CNC metal, but at least in my experience, it can do aluminum pretty well. But now, of course, for the real test, is all this stuff going to fit together, and is it going to work? I'm pretty confident these holes will line up because they lined up on the piece of paper that I laser cut before, but it was kind of hard to verify the alignment on the chassis itself with that paper method. As you can see, the holes themselves do line up with the slots, which is a good start. And with these about in the middle of those slots, it should line up pretty much perfectly with the spur gear. I'm just going to hold this spur gear in place, and yeah, it looks like this is going to work perfectly. This is the beauty of having a CNC machine, and to be honest with you, having that 3-in-1 capability makes it to where you can make just about whatever you want. Now, obviously, you could probably 3D print the motor mount, though heat and nitro fuel compatibility might be a problem, but you're not going to 3D print these slots in the chassis. This would be really hard to do manually. Speaking of doing things manually, this motor is going to provide the go, hopefully, but it's not going to provide the stop, which means we've got to put some brakes on it, and that's where this bag comes into play. This is the entire rear drift brake system off of an Arrma Fireteam, and this is what we're going to use to stop this truck. Unfortunately, the primary mounting for this utilizes the stock C-block, and we don't have the stock C-block on here, so we're going to have to swap out these M2C parts. Otherwise, I'm not going to have any way to mount this up. So let's get this swapped out, and hopefully this thing's going to work. If you enjoy wild custom projects like this, make sure you get subscribed because I have a ton of really cool ideas coming up, and assuming I can pull it off, one of them is going to be something you've never seen before. Okay, it looks like this mount replaces the plastic piece on the C-block, so we should be able to just get this installed on here. Then the brake disc goes on, fits on there perfectly, and then the rest of this should just slide over the top, which it does, and then this should go on the chassis. I'll have to do some programming on the transmitter like I mentioned earlier, but now we should have brakes on this truck. That rear brake setup is why we're running a locker instead of a center differential. If we had a center differential, when we brake the rear end, it would just end up bleeding that energy off and we wouldn't actually get full braking action. This should fix that problem. To keep things nice and lightweight, we're going to stick with the titanium ram jam rear drive shaft. But on the front, we're not going with the titanium drive shaft, at least not at first, because I want to make this thing two-wheel drive, again, giving it the best chance of working we can. Two-wheel drive gives this thing less weight, less rotating mass, and less parasitic drag. And unless this engine turns out to be way more powerful than I think it's going to be, I don't think we're really going to need the traction of four-wheel drive. Of course, we always have the option to add it later if it's necessary. Obviously, we're going to leave the center drive shaft out, and then we're just going to take these CVDs out of the stub axles. Of course, we still need to use the stub axles because those hold the wheels on, but the CVDs pop right out, and then we can put these right back in, and now it's a two-wheel drive truck. And with that, the Kraton Superleggera is just about ready to go. Now, before we put this engine in, we need to install these sweet new adjustable pillow ball retainers for the new V6 front hubs. These are prototypes from M2C, and unlike the stock plastic ones, which aren't adjustable, these have an aluminum outer part and then an adjustable threaded inner part that's made out of Delrin. And this means over time, as it wears, you'll be able to screw this in and keep your pillow balls adjusted just the way you want them. Again, these are a prototype that I'm testing, so I don't know if they're going to be available by the time this video comes out. But they certainly look awesome, and the adjustability is going to be really nice for people that like to get every bit of play out of their suspension. And now finally, it's time to go ahead and get our engine in. Uh-oh. It looks like we've got an interference issue back here with the brake servo. As you can see, the fan's definitely going to be hitting. These kinds of problems are really common when you're doing a custom build like this, and we're just going to have to figure out how to work around it. Of course, this servo has to go somewhere, and if it won't fit on this side, the only other place to put it's on this side. Let's see if it'll fit. So it looks like what we might be able to do is put it in right here, screw it to the mount here, and then just flip the linkage around, and I think that's going to work. Let's see if that's going to clear with the engine installed. And yes, it looks like everything will just barely clear, so let me go ahead and get this modification done, and I'll show you what it looks like. There we go. And while it's not perfect, it does braking things, so I'm pretty sure it's going to work. While I was at it, I also added a throttle servo to the engine, which means it's finally time to get this thing installed. By the way, I'd highly recommend you turn on post notifications. I do a lot of giveaways on this channel, but I hide them in videos, and I always announce the winner in a community post, so if you don't have those post notifications turned on, you might miss finding out that you won something really cool. And now the moment of truth, does it all line up and does it all fit? Kind of amazingly, it seems like the answer is yes, everything does fit. Now, is this thing actually going to be able to push the car? Let me get some electronics wired up, put some tires in this thing, and let's go find out. All right, guys, first try with what I think is the world's first two-cylinder nitro-powered Arrma Kraton. Here we go. Okay, she runs, but will she move? It does move. Oh my God, that's so awesome. Look, it runs. It sounds cool too. Will it jump? It jumps. It's not exactly powerful, but it definitely runs and it definitely moves. Rear-wheel drive's pretty fun too. It's actually running pretty darn well. I'm very surprised. I figured this was going to be a lot more problematic. I did do some engine tuning off camera, but not a lot, and this thing's running absolutely great. I'm actually really curious to see if it runs better on gas than it does on nitro, but so far, I'm pretty impressed with its nitro performance. Obviously, this is nowhere near the performance you're going to get with its original electric power system, but this thing's pretty undersized for what it is, and overall, I'm pretty darn impressed with it. Oh man. Guys, this has been about a week of work that you've seen in the last 15 minutes of this video, and I'm so happy to see that it's actually working properly. This is way, way better than I could have hoped for, and I'm so excited to be sharing this with you guys. This thing runs awesome! Look at her go! As I'm sure you guys could hear, I could not be happier with how this turned out. But of course, Engine DIY also provided a gasoline conversion kit for this thing, and I said we were gonna try it on gas, so let me get this thing converted and let's find out if it's gonna work. Before we get into that, we need to talk about the Snapmaker Artisan. First of all, I wanna say I'm incredibly impressed with this thing. The hardware on it is absolutely gorgeous. I have dealt with a lot of hardware over the years, and this is one of the most beautifully designed and manufactured pieces of equipment I've ever used. Obviously, a ton of thought went into the hardware on it. This is a very expensive machine, but you're also getting a lot for your money. If you looked up how much it would cost to separately buy a 400 by 400 millimeter bed 3D printer, a 40-watt laser cutter, and a 400 by 400 millimeter CNC router, it would be more than what you're spending here. You also get a beautiful enclosure, and again, the build quality is amazing. I found the 3D printer to be perfectly competent, the laser module works fine, and the CNC machine actually impressed me the most. For only having a 200-watt spindle and for how big the machine is, this thing was surprisingly rigid and made some really nice clean cuts. I found the accuracy was within about 0.1 millimeter, and whereas that's not precise enough for really high precision parts, it's good enough for most tasks. The only real issue I had was with the software. The Luban software that they have that works with all three of these modules is okay, but I personally ended up using a different piece of software for each individual module. I used Orca Slicer for 3D printing, I used Lightburn for laser cutting, and I used Fusion 360 for CNC machining. This is fine, but I wish their software worked better with all of these different systems. There are other companies out there that have created software that's a bit more user-friendly, and if the software that came along with this was more user-friendly, it would make this machine a complete no-brainer for anybody that needs these kinds of systems. As it is, I still think it's a great thing, especially if you have limited space, but I'm hoping they continue to develop their software so it becomes a little bit more of a cohesive package. Ultimately though, I love this thing and we'll definitely be seeing more of it in future videos. And now finally, here we go guys, one gasoline-powered Arrma Kraton. You can see the spark plugs and spark plug wires there, and an absolute mess of wiring. Now, I'm really not sure this is gonna work, and a big reason for that is I didn't get any instructions with this kit, so I was kind of left to guess on quite a few different things. I don't blame Engine DIY for this, even though they sold me the kit, they don't make the kit, and it's really the responsibility of the manufacturer to tell me what I'm supposed to do with it. Fortunately, I've done stuff like this before, so I think I've got it right, but the proof's in the pudding. Let's go put some gasoline in this tank and see if I did. All right guys, gas power, let's see if it starts. It's running. Will it move? There it goes. It is a gas-powered Arrma Kraton. It's not moving very fast, but and it stopped. All right, let's try that again. Well guys, try as I might, that's the best power I could make on gasoline, and to be honest with you, I'm not terribly surprised. Whereas gasoline is somewhat more energy dense than nitromethane, the mixture for nitromethane is far richer than it is for gasoline. So overall, nitromethane can make a lot more power than gasoline can, and I suspect this engine is set up for nitromethane. So I really didn't think it was gonna run well on gas. I'm honestly kind of surprised it ran at all. But it ran, it moved, even though it was a crawler, we did make a gasoline-powered Arrma Kraton. Thank you so much for joining me on this journey. I had a lot of fun. I'm glad you were here. Why don't you join me in one of these videos?